Welcome to Database Management System series of lectures. Today we'll be discussing about Unit 2, Topic 2, E of Chord rules. E of Chord is a famous computer scientist named as Dr. Edgar F. Chord. He has proposed various rules for defining a relational database model. He has outlined how a database management system should be defined in terms of relationals. So RDBMS is a database model that is defined by E of Chord. He has framed various rules, and these rules are popularly called as E of Chord rules. It starts from 0 till 12. Let us look at these rules in detail. The first one is Rule 0, that is foundation rule. Rule 0 is foundation rule. This rule helps us to understand, foundation rule helps us to understand what is the foundation on top of which the database system is defined. That means every data which is being created in RDBMS should follow the structure of a relation. That means every data which is being stored in the database, in relational database, should be represented in terms of a table, rows, and columns. Let us take to understand this better. Let us look at the example. Let us create a table called student. So student ID, student name, and marks of one particular subject. So this is a table which is created. So here it indicates that all the data about the student should be stored in terms of a table-like structure. That is 100 is the student ID, name is Arun with marks 50. All the information about the student should be stored in terms of a table, and these are called as records. And these are columns. Right? So the meaning of foundation rule is you should not violate the rule of going with relations. Second rule is information rule. Information rule indicates that information rule indicates that information rule indicates that in database everything is available. So you are accessed to the data. You are accessed to the data in terms of combination of both table name and column name with primary key and attributes. So with the combination of these three things together, we will be able to access to one specific record. Now, the third rule is guaranteed access rule. The third rule is guaranteed access rule, which means that whatever the data which is stored in the database is definitely accessible by every user. Rule 3, that is systematic treatment of null values. Here, what are null values? Let us say that we have a table for student, which has student ID, name, and subject 1 marks and subject 2 marks. Okay. Student ID is represented as 100 and name is Arun. If this student is absent for subject 1 test, let us say that there is no data which is stored, but for the second subject, there is a value which is existing as 50. Now here, there is an empty field with respect to student roll number 100. So this leads to incompleteness of data. This leads to incompleteness of data. Now, this data can be understandable or misinterpreted either as absent or either present, but the marks are missing. Present, but the marks are missing. So which one can be taken into consideration? So this missing value should be treated properly such that if it is an absent, then mark it as A. If the student is present but got the marks to be 0, then it should be given as 0. So this is how we handle the null values. Now, so it is active or dynamic online catalog. Active or dynamic online catalog, which indicates that if the database is defined, then the structure of the database or the information about the database or the metadata about the database should be made available to every user across the world. So this data should be made available and accessible to everyone who is working or dealing with the database. Rule 5, that is comprehensive data sublanguage rule. Rule 5 states that make sure that we use a specific language called as SQL language, that is structured query language. This language should be used for the purpose of defining the data, for updating the data in the database, and for querying the data in the database, as well as for manipulating the data in the database. So to perform any kind of operations, we should use only one uniform language. There should not be any other language which can be used for performing any kind of operations. Rule 6 is view updating rule. This rule states that you can create n number of tables, right? And you can define a view which can extract few of the attributes from various tables. If the view has presented certain content from various tables, then it should also be equally reflected in the main tables. There should not be any difference from the view of the data as well as the physical data which is stored in the memory. Next is views. Next is rule 7, that is relational level operations rule. This rule indicates that whatever may be the operation that we are performing, whether it could be creating the table or creating a view, updating the contents in the database, or modifying the data in the database, everything should be done in terms of relational database management system principles only. Right? Now, the next is rule 8, that is physical data independence rule. Now, this is the underlying database, the physical level wherein the actual data is being stored on the disk. Physical data independence rule states that if any applications that are used by the users for accessing to the data should not be affected with the internal representation of the data. Okay. So if user is interacting with the data through any kind of applications, should not change the data which is being stored in the memory. So there must and should be transparency that have to be maintained. The next is rule 9, logical data independence rule. If any changes in the underlying structure of the database should not have an impact at the applications level. Because when the user is interacting with the database through the applications, then the structure of the database should not be modifiable. Next is rule 10, integrity independence rule. Now, what do you mean by an integrity? To maintain data in the database in a correct manner, we follow various integrity rules, integrity constraints for the purpose of maintaining completeness of the data, correctness of the data, as well as accessibility to the data. So what are these integrity constraints? We have primary key constraints, which indicates that you can access to every record in the database using one particular attribute, which can uniquely define that record. We have checker constraint, which indicates that every time when the data is being inserted into the table, should be checked against to that value. If the value is going beyond this range, then it should obstruct immediately, not to perform the insertions. So these kind of integrity constraints helps us for the better maintenance of the system. Next is rule 11, that is distribution independence rule. Distribution independence rule tells that if the data is being stored at various other locations, various other geographical locations, and this data can be accessible from anywhere with the help of internet connectivity. The data which is being accessible from any particular location should give the same correct information. So distributed here is nothing but the data is being maintained in various computers or at various locations, but it should be given with same type of data, same content of data. So this leads to distributed databases. Okay. Now, next is the last rule of E of CORD is non-subversion rule. Non-subversion rule indicates that we cannot violate the rules stated by RDBMS. Okay. If the data is being stored in the database and if any interface or the application has given a provision to access to the data, then it should not allow to change the structure of the database or to the data. It should not violate the principle of guaranteed access rule. You can access to the data, but it should not modify the content in the database. Okay. So this means that we should not violate the security policies which are stated by the RDBMS. So these are 0 to 12 E of CORD rules, which are defined for the purpose of proper maintenance of relational database management system. Thank you.